Okay, so coordinate grid. What are some things we can do between points? So let's say A and C, we can find certain things. We can find like the line equation between A and C. Yeah, we can find the slope between A and C. So let's just write down some things we could find between A and C. We could find the slope. We could find what else? The line equation. We might be interested in the midpoint, right? The point that's exactly in the center of that. Maybe we're trying to draw a circle. And then now I'm going to try and draw a circle. And we want to find the center. So maybe we need the midpoint. Yeah, rise and run. So that's slope, rise over run. We find the difference of your y's because that's the rise, right? And the difference of the x's, so that's the run and the rise, right? Okay, anything else? We can actually also find the distance between these 2 points. And if we can also actually, and you probably haven't learned this yet, but we could find the relationship needed to graph this circle that I just drew. Like I could draw a circle between AC, or I could make A the center and up to C would be the radius. So we can actually do circle equations. We're going to get to that later. They're actually not as bad as you may think. Yeah, so I mean, the line equations piece, I'm assuming you've seen that in all the previous courses. There are a bunch of videos on that. So we'll come back to slope and line equations, but let's just think about midpoint and distance right now. We'll focus in on that. Okay, so let's just try to think about how we would get midpoint. So a midpoint is the point in between. It's the directly in the center between the 2 points. So the distance has to be the same on each side of it. So there's a way to do that. And the strategy here is to figure out what the exact half is here for the x values and what the half is here for the y values. And then, so then that gives us the midpoint. Okay. So if this is 1, 4, so this is at 1 and this is at 4, what's this? We can figure out the distance and then we can figure out smack in the middle. So what's smack in the middle between 1 and 4? 2.5. Yeah. Yeah, so 2.5 would be right in the middle, but how do we find that in general, right? Like how do we know that between 1 and 4, the center is at 2.5? So how did you find 2.5 from 1 and 4? Other than looking at it. You could look at it, right? You could go 4 minus 1 is the distance, divide that by 2 and then add it to 1. So that's kind of a little bit of a longer process, but you could do that like visually. Another way to get a number that's right smack in the middle between two numbers. Think of what you do when you figure out, let's say you got 60% on a quiz and 80% on a quiz, and a past teacher's like, I take the average. So what's the average of 60 and 80? 70, right? Average of 60 and 80 is 70. And isn't 70 smack in the middle between 60 and 80? So isn't taking an average actually finding the middle point? It turns out that average and midpoint are basically the same concept. when you take an average of things, you're finding the middle point in between those things, especially when there's only two of them. So let's try that. 1 plus 4 over 2, that's the average of 1 and 4. What happens to that? 5 over 2, which is 2.5. So this is my x value. So at 2.5 is going to give me my midpoint. And then I also need to get an average for my y's. So what's the average between 4 and 6? Cool. So to summarize, your midpoint is always going to be a coordinate, and you're going to have the average of your x's and the average of your y's. The reason why I write it like that rather than writing it with all sorts of x1s and y2s and things like that is because if you think of it as an average, if you think of midpoint literally being average, then you don't have to memorize a formula. Like the formula ends up looking like x1 from 0.1 plus x2 from 0.2 over 2, right? And then y1 plus y2 over 2. But I end up getting a lot of mistakes when people try to memorize these because there's a lot of other formulas that also include those. But if you just think of average, it's going to help you out. And so in this case, my midpoint is 2.5 for my x value and 5 for my y value. Okay, so that's midpoint. So let's try to take that again, but now let's talk about distance. Okay, so I'll redraw those points. Again, we'll have do this one. This is the x and the y component. And this distance here is what we're interested in. So does this look familiar at all, this shape? Yes. Okay. Any guesses on how we could find this distance? What kind of thing could we use that we've learned before? If we were in class, I would chant, you would all chant, because I would say a squared plus b squared is, and then everyone usually responds c squared. Not that, like, sometimes you just remember that formula and you're not sure where it comes from and what it's used for, but this is to do with a right angle triangle. Yes, this is a Pythagorean theorem. For any right angle triangle in general, if this A and B are the lengths of the sides, then when we square them, you get the area of that. And if you square B, you get the area of B. And when we add these areas, we always end up getting the exact same area as the hypotenuse squared. People have made little models where they put sand in here and then they check and then they pour it into the last rectangle, or water. Someone made like a rotating water thing where the A squared and B squared are always filling C squared, and it's always true. And this actually works for any other shape. It just squares are easiest, but I could have taken the area of this half circle plus this half circle, it would equal this half circle. It doesn't matter what shape I create as long as the base is the same and the two shorter sides are equaling the third. This only works for right angle triangles. So it's a relationship that's been found from ancient times and also in different cultures as well, in different ways. So that brings us back to, okay, we have 2 points, we want to find the distance. We need some way of figuring out that blue distance and a way of figuring out that green distance only from the points that we've been given. So what is this blue distance right here? 4 minus 1, yeah. And that comes from my x values, because this is an x component. This was at 4, and then minus 1. So if I take 4 and I take away 1, I get this rest of the distance here. So in this case, technically, this is like x2 minus x1, if I'm thinking this is my 0.2 and 0.1. To be technical, that's what that would look like, which is actually 3. So that distance is 3. I'm just going to keep it like this for now. And now somebody type what you would do to find the green distance. Okay. So 6 minus 4, yeah. So if you go 6 minus 4, that's like your y2 minus y1. So really that blue distance is your A, and your green distance is your B, and then your orange distance is C, right? So if we think of the Pythagorean theorem and we follow A squared plus B squared is C squared, what that gives us is, and I'm going to do it generally, my difference of x's squared plus my difference of y's squared. It doesn't really matter what order you subtract them because you're going to square them, the sign's going to change, is my distance of my hypotenuse squared. And so rather than having d squared, the formula will end up square rooting both sides, which then it'll be d equals the square root of the difference of the x's, difference of the y's. Right, so that's like your generalization that you can use at any point. But this other sort of format here also works. In fact, we're going to come back to it in a sec. And so in this particular case, if you're finding it between 1, 4 and 4, 6, you're going 4 minus 1 squared plus 6 minus 4 squared equals my d squared. And so my d squared is going to be, and you're going to, calculate all that. 3 squared plus, what is that? 2 squared. So 9 plus 4 is 13. And so if you square root that, you get root 13 is the exact value distance of D. If we did this for like these 2 points, point A, 1, 4, and 2.55, it would probably have to end up being root 13 over 2 because it's halfway. That would be a more complicated one. But the process is still the same. So anytime it's asking you about a distance between 2 points, even if these points are like way, they've got negatives and things like that. So let's say it was -2, -1, and then, I don't know, 6, 3, right? You could find this distance, whatever that is. You don't have to graph it really. You just know that when you're doing distance, you have this kind of in your mind. So why don't you try this on your paper, like find the distance between these 2 points in an exact value format. And then you can also think about what the slope would be, because the slope is similar but slightly different than the distance calculation, as well as the midpoint. So you should be thinking about, okay, how do I find slope? How do I find distance? And, how do I find midpoint? These are things we can find between 2 points. Okay, I'll give you like 2 or 3 minutes. Try it out. Okay, well, I got a distance, but feel free to correct me or ask questions about how I went about that. Perhaps it's slightly different than the way you did it. That's totally fine. As long as you kind of get to the same answer. You might have started with -2 and gone -6. That's fine as well, as long as you do it the same in both ways. Yeah, I know that's a little hard to type in chat. Okay, cool. And then midpoint was 2, 1. I don't know if you got the same. That's cool. Yep. And for slope, now, funny fact about slope. Slope is signified by a small m and midpoint is a big M. So the reason why it's not S for slope is because It was discovered and worked on by a French mathematician, René Descartes, the philosopher, and he's French. And so what's M stand for in French? Well, it stands for monter, like to climb. So if you didn't know that, I always wondered, why don't they just write S? But it's because it was French, not English. So this is a really tricky part. A lot of people forget to put the Y, the rise first. So the rise, the difference of, sorry, that's wrong. The difference of the Y values over the difference of the X values. And you'll actually see that in your distance formula, we took the difference of the Y values. Up top, 3 minus -1, and then up on the bottom was your X values. And again, you could have gone the other way as long as you maintain consistency with the direction between labeling 0.1 and 0.2 in the same way. So you get 1/2. So it's generally going up 1 over 2. So it does actually cross through 0. I just didn't draw it very well. Right? So it goes through 0. So, you know, a line equation, if you're kind of reviewing line equations, remember you have your y equals mx plus b was your general formula of a line, general sort of relation there. And so if our slope is 1/2, we're going to have y equals half x, and our b is usually our y-intercept. In this case, it's 0. So we have a line equation. We also have our midpoint. We have our slope. We have our distance between these 2 points. So that's quite a bit. We've got a lot of information about just these 2 points. You know, in the line section, you might be given 2 points and it'll say write a line equation. You may want to review how to do that. Essentially, you could plug it all back into y equals mx plus b if you know your m. And then because what's happening here is we're basically stating a relationship of all the xy pairs that make the equation true. We could take one of our xy pairs and throw it in as a pair and then solve for b if we didn't know b. So if we knew our 1/2 x, or 1/2 is our slope from our 2 points, and then we also knew that, you know, 6, 3 is a point. So I could say this and then solve for b and find b, and then I'd have my line equation if b was not so nice in this case. So that's just a quick review of that. We will, you know, come back to that. So the next thing that we can do with kind of 2 points along this line is circles and Desmos. So if you were trying to, you know, graph a bunch of things on Desmos, and some people like to make little drawings, like if you look up Desmos art, you start seeing like some crazy shapes and things that people draw, right? Like, so if someone wanted to draw this little skateboard guy, they're going to need a circle for the face. They're going to need parabolas, right? You have parabolas, you have lines, you have different segments, and each segment has like a domain and range that is defined. And so that's how they can draw things. And so our goal in module 3 is to start learning about some of these shapes, right? Like, so circles, how we draw a circle relationship, so that all the points that satisfy the equation of XY pairs form a circle when they're graphed. You've learned about parabolas perhaps in the past. You can see they've used a lot of parabolas. They've also used some lines, but they're kind of line segments. So they basically say, like, I don't know, y equals 2x plus 3, but then they'll define x to be between, I don't know, 1 and 4. And then that'll graph a segment. Again, circles. Ellipses are a little more complicated. They're kind of like circle equations, though. So yeah, I mean, this is just, I'm generalizing here, but that's the broad goal of, like, in this course, you're starting to see different shapes, not just lines. Okay, so let's focus on circles today. Okay, So a circle, let's just think of the definition of a circle. Like, how would you create a circle if you were trying to create a circle just in life, daily life? What would you do? We got to have a center, right? Yeah, that's right. Very good. So you need a center point, right? Just like with a line, you need a slope and one point, right? With a line, you need a slope and a point to define the line. That's essentially what we need. For a circle, we need a center point or any point on the circle, but center point is helpful. And let's say we wanted it to be 2 away from the center. So that'll be 1 point. That'll be another point. Sorry, I drew 4 actually, 4 away. So now it's 4. What's that called? Starts with an R. Yeah, close. Diameter, actually. Diameter is the total. So the anatomy of a circle, this whole thing is a diameter. And excuse my circle drawing skills. I'm trying, right? But I'm looking for the name of this part. It starts with an R. Radius. Okay, good. So we need a center and a radius. Okay, and so the circle is basically defined by an equal distance away from a center. All of the points on this outside circle were equidistant from the center. So what that means is we have to find a way to write an equation that captures that. And so one way to do that is, whoops, just gonna remove diameter because I don't want, like if you are given the diameter, you'll just take half of it, then you'll know your radius, right? So let's say this radius, because right now this radius between here 4, 2 and 8, 2, that one's obvious. I can figure out what the length of that radius is. I know it's 4. That's great. But how do I maintain that relationship so that any point, any random point x, y on the circle will be defined as 4 away from that center? That's essentially what we're concerned about. If that makes sense, right? So the way we can get Desmos to graph the circle is we have to define the xy in a way that maintains a distance of the radius away from the center. And again, I'm going to draw something that is going to be familiar to you. Okay. So what's this distance? Yes, it's 4. Because why? It's the radius. The radius is always going to be defining the circle as 4 away from the center. So all points have to be 4 away from the center. That's fixed. Like I know that that is there. That is true. So now, don't I have a very familiar looking shape here? It is again a right triangle. So just like before, when we were looking at distance between 2 points and we used this right here, the Pythagorean theorem, we can use that exact same strategy here to define a circle, right? So right now I have 2 points, 4, 2, and xy. Those are my 2 points that I'm looking at in terms of basically writing the distance equation for. It's just xy is going to be general. And I'm going to start with x because I want x to be there. So this part, this orange part is going to be the difference of my x's. It's going to be x minus 4. And the green part is going to be the difference of my y's because it's the rise, y minus 2, right? So basically now I have this squared plus this squared is that squared. It's my Pythagorean theorem. So I have my x minus 4 squared plus y minus 2 squared has to be the radius squared. So this is the common error, is to forget that that radius in the equation is squared, because c is squared to make the equation true. It's easy to think, oh, it's a 4, it's already a perfect square, but no, it could have been a 5 or a 7 or whatever. Okay, so that's our circle equation. So let's try that in Desmos, see if we can graph this circle that has center 4, 2. Notice where it's coming from in the equation, and radius 4. Okay. We go to Desmos, clear those things away. And so x minus, what was it, 4, I think? My memory is kind of terrible sometimes. Y minus 2 equals, not 4, because that's too small, 16. Okay, did we do it? We did it, right? Okay, so just watch carefully. That 4, 2, even though that's a minus 4, this is a positive 4 and positive 2, because remember, to find the distance, we had to minus, and so that number was positive. If you had x plus 4, then your x value would have been a negative 4, right? If it was like that, then the center would have been the opposite. So 4, 2 is the center, and your radius is a distance of 4 all the way around anywhere. And it's scaled a little bit funny there, so you can't really see all of it there. But okay, so knowing that, I want you to try to tell me, I'll give you a minute in the chat to think about how you would write a equation into Desmos so that it graphs a circle with center, say 2, -3, and radius 5. Okay, so what would the equation be if I wanted to graph this circle, the relationship of this circle? What's my equation? So if your center is 2, -3, so that means that this is not the right graph, so we're just going to grab a blank page. Let's say your center is 2, -3, right? And your radius is 5. So anywhere you move, it has to be 5 away, anywhere. Right? That's how you'd form the circle, is if you instructed a computer to only go 5 away. And the way we go 5 away is there's an x component to that and a y component of that. So this is an xy on my equation. 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 Xy is general of any point that is satisfying the equation. It's going to have a lot of answers, and those answers are going to form the circle, right? Okay. So, but we can think of distance as basically the hypotenuse of the right angle triangle, right? And so this point was at, on the x-axis was at 2, and this point was at wherever x was. It doesn't matter if I go 2 minus x or x minus 2. When I square it, it's going to be the same, like it's the same difference. And that's that distance. So that's my x component. And then my y component is going to be, this was at -3, and this was at wherever y was. And again, these are moving points. The x and y can be anywhere. So I've just kind of placed a random one to be able to describe it. But it should work for anything. Like if I try and create that triangle here, it'll be the same thing. It'll still be the x values are at 2 and wherever x is. So x minus 2 is going to be this distance, and negative y minus negative 3 is going to be this distance. And then I have the d has to be 5. So either way, I have my x minus 2. So my x values being taken away is my a squared, and then my b squared. My b squared is my y values, y plus 3 because it's y minus negative 3 squared. And then I want it to equal my radius squared. And the radius squared is 5 squared. So if I type in this into Desmos, I should get all the points that are 5 away from 2, negative 3, right? So again, this is our a squared and our b squared. So 2, negative 3 should be our center, and that equals our r squared, which is 25. Let's see if that works. It's kind of hard to see where the center is, but I can plot to negative 3. Center, right? And then if I wanted to check my distance, I could take any point that is on here. Any of these, see how a lot of them are decimals? Any of those points, so the x and the y, if I plug it back into that equation, I'll have kind of like the Pythagorean theorem again, right? So this point here is a nice point, 2, negative 2, 0. I should be able to take, I'm just saying, like, once I have this down, I can play around with it. Between negative 2, 0, which is a point on this circle, and 2, negative 3, which was our center, that distance, if I calculate the distance, should be 5. And you'll notice when I calculate distance, that's essentially this equation. So really a circle definition is a distance equation with a general xy term. How does this extend? Well, sometimes, now that we know the general form of a circle, you might see something like this. There's a question on Alex similar to this, where they say, here's an equation of a circle, and you can tell it's a circle because it's got both x squared and y squared. If I only had x squared but y was not squared, it'd be a parabola, right? If I'd had a square root, it would be something else. If I had, right? So circle, you can tell it's a circle right away because both x squared and y squared are there. And so this is not in a very nice format. Like our general format was x minus h they usually use, plus h as a general, and y minus k is r squared. That's the general format of a circle with center hk. I don't know why they use those letters, and radius r. So we need to get it into that. So the trick here is to put it into that format. And so to put it in that format, we actually have to do something that we learned last class when we were trying to, do you remember when we were trying to get a perfect square so that we could like square root both sides? I'm going to rewrite this. I'm going to put my x's together. I'm going to leave some space, and then I'm going to add the 3 to the other side. Yeah, completing the square. That's right, except now we have a double scenario because we want to complete the square on the x's and we want to complete the square on the y so that we can figure out what the center is and what the radius is. Right now, this 3 This might not stay a 3 because it might get compensated for by what we add. So take a minute and think about what you need to add for the x part in order to make that a perfect square, and what you need to add for the y part to make that a perfect square. Okay, 9 and 4, yeah. So remember, half of the middle term squared gave us the perfect part. That would make this an x minus 3. And you can multiply that out and check it and see. But remember, we added that 9. So if we added it to the left side, we either have to subtract it right away, or in this case, there's no brackets or anything, so I could just add it to the other side to compensate, right? But I can't just add this 9 without compensating, either by subtracting it right away and then adding it to the other side after, or adding it to the other side right away. And then the 4. So half of the middle term squared, so plus 4, that's going to be y plus, so that 2, because 2 squared is going to give us 4. This is always a plus. And now we have to compensate for adding that 4. We'll just add it to the other side right away. Right? Does that make sense? We're basically forcing it to be in a perfect square format. So, okay, try this out. 3 and 9 and 4. What does that give us? 16, yeah? Okay, so who can tell me what the radius is and what the center is? We've gotten it in this nice format. What's the center? What's the radius? Yep, radius is 4 because it's the square root of the perfect square there. If it is not simplifiable, just leave it as a root or simplify the root as well. And then, yeah, so 3. So now careful with the radius. It's a little, remember it's opposite, right? Because this was the minus was coming from the fact that you were minusing the 2 numbers. So this would have been a 3 to make it work. You can think of it as like what zeros it out. 3 would zero it out, and then a -2 would zero it out. Okay, so we can graph that and check it as well, but you'll always notice that inside the bracket of the x, you'll have an opposite sign of the shift. Outside of the brackets, the shifts will be regular. We will talk about transformations later when we do like parabolas and transformations like that. Cool. Okay, so I mean, we can have all sorts of questions about circles. Find an equation of a circle that has this center passes through this. So again, you would take your x minus h squared plus y minus k squared equals r squared, just like if you had to do y equals mx plus b and fill pieces in that you do know and then find what you don't know. Same strategy, right? Like just fill in what you know. So if the center is -2, that's my hk. And I don't know the radius, but I do know that 1, 7 is a point that should work for this. So I'm going to plug in for now a 1 and a 7 here, because that's now going to help me calculate the radius, and then I'll be able to throw it all together once I know the radius. So anytime you have other information provided, just throw it all into the general form of the equation, solve for what you don't know, and then you know it. So yeah, 1 minus -2. And again, this is a distance formula, right? So radius is √13. So the equation of the circle, now I go and answer my question. I know it's x plus 2 squared because it was the opposite, and y minus 5 squared, it was the opposite, equals √13 squared, which is just 13.